Greetings everyone, today we will learn 4th chapter kinematics. This will be the first lecture of this series. 4th chapter kinematics, lecture number first part of kinematics. So in this lecture students, we will discuss motion in a straight line. So let's see motion in a straight line. First let's start with kinematics. Kinematics. What is kinematics? So kinematics is generally two words, kine plus matics, which also means motion plus mathematics. Okay students, so I can say the study of motion of an object is kinematics. The study of motion of an object is kinematics. And it is done through the help of mathematics, so that is why. Kina is basically a Greek word which stands for motion. Second part, translation motion. So motion of an object to cover linear distance. To cover what is students? Linear distance is done through the board. Linear distance is done through translation or translatory motion. Let me explain this to you. So a student would be saying that, sir, you were supposed to publish on Wednesday and you are publishing on some other day. It's done through translatory or translation motion Right students? Yes sir, we have understood this. To cover linear distance, yes. So let me explain translation motion for now. How many type of them are? Translation motion is of two types. So one would be thinking that what is translation motion? It is to cover linear distance is translation motion, but how? Is of two types. First is rectilinear motion. Just let me explain one by one. Rectilinear motion. Rectilinear motion is what? Motion in a straight line is rectilinear motion. When an object moves, so what is happening? Motion in a straight line. Right students? Yes sir. So erase this. This is, so let us draw. This is rectilinear motion students. So we have 2 points A and B, right students? A and B, and this is rectilinear motion. First case, Now, motion in a straight line, curvilinear motion. What is curvilinear motion? Motion in a curved path. Motion in a curved path is curvilinear. In a curved path is curvilinear motion. So let me give an example. This is me traveling, and this is what? Yes, point A and B. Okay. So this is curvilinear motion. You see the path covered can be straight, but it is not. So it is curved path and therefore curvilinear motion. One example of translation motion. So these are the two types of translation motion we do. Of course, to cover linear distance. Now the next part. What is the next part? Frame of reference. Very good, students. Frame of reference. So you would be asking, sir, how could frame of reference is coming into this play? How frame of reference is coming into this play? So frame of reference. Actually, students, I want to use here a property for frame of reference that we will have in our future, in the coming lecture. It is the coordinate system. It is the coordinate system with respect to an observer or reference point, Okay, so let me explain this to you. Not here, sir. You can't explain here. So, frame of reference. Generally, as the statement goes, this is frame of reference X, Y. I'm not drawing Z. Suppose this is my coordinate system, I'm in Delhi. Okay, so my origin is what? Delhi. And this is you sitting in Hyderabad watching this lecture. So what is this here? This is your coordinate system, and I would say Hyderabad is your origin. So the thing as it follows that this is one frame of reference for you, this is one frame of reference for me. Hyderabad is your frame of reference, where origin is of course Hyderabad and Delhi is mine. So the next, so what is the starting point for you might not be starting point for me. So the next, so what we were discussing, yes, about publishing, there was certain issue that came. Trajectory, the path followed by a point object during its motion is called its trajectory. Okay, students. Sir, can you give an example? Yes, of course, sir, students. Suppose this I am standing here, point is my mic. So I am following a certain path, walking here and there. My mic is following the same path. So I would say the mic has certain trajectory that it follows with my movement. Of course, during its motion. So the next thing, trajectory equation. What is trajectory equation? People say that this is trajectory equation and everything in physics. So let's see trajectory equation. Trajectory equation. Oh sir, why you are so in a hurry? Trajectory equation. Trajectory equation. Trajectory equation. What it means, students, if x coordinate of an object at all points trace such that they are defined by a mathematical function of corresponding y coordinates. So even the board is y coordinates. So it is also due to the physics. You go much down and it happens. If x coordinates of an object at all points trace such that they are defined by a mathematical function. Let me explain this to you by an example. Sometimes in physics definition are not enough. You need what? Diagrams and everything. Diagrams are much better, I would say. Diagrams are way better. So let us see what is happening here. Nothing much is happening as the definition goes. So this is the trajectory and this is what point P of an object. Okay. This is path it is following. And this is point xy. So x is here, students. Yes, no? Yes, sir. So y is here. Okay, students. So point P, object is traveling this way. I am taking here this point P. So this is whichever relation is satisfied between y and x is called trajectory equation. Suppose I am taking y is equal to x square, y is equal to sin x. These are what? Trajectory equations, etc. Next, so you have understood the thing. Motion of an object you can take cube also here. Sir, wouldn't it make the thing as volume? No, students. This when you write cube, this is not 2. I am taking 2 it is actually the value being cubic and meter means meter. Otherwise, if volume would occur, I would write x, y and z for volume. Okay, so the thing. 3 coordinates I need. Motion of an object under gravity. Under gravity. Right, this is function na? Yx square sin x within a system under gravity. So what is the motion under gravity, student? So free fall. Yes, definitely. It is free fall. But sir, free fall is actually about things under gravity, or we can add to the term. We can apply force to the thing. No, students, this is not possible. You can't apply in free fall any force other than gravitational force of the earth. Free fall. Free fall. An object falling under gravitational force of earth, falling under gravitational force of earth, mother earth. Yes sir, definitely mother earth. Sign conventions. What are the sign conventions, sir? Sir, they could be like positive goes into positive direction. So this is y coordinate, and this is what? Positive I would write. Positive direction. Right, students? You are understanding the thing, na? This is what? Negative direction of y. So I would write negative direction. Right, students? Yes sir, we got your thing. So I am taking this, what is student? This is first case. This is again second case. Okay. So once understood, the students, physics is joyful from the beginning. But if not understood from the beginning, it appears to be dry subject. So first case, let me discuss the first case. Case first. Displacement. What is happening in first case? Oh, it is going upward. Displacement against gravity is taken to be what? Positive h, positive height. Second, this is first case. Second, velocity against gravity, whether it's initial or final, is taken to be what? Positive u, very nice, and positive v, positive final velocity. Okay. And this is third, what? Acceleration under gravity always is minus g. So it is minus g. Case second. What the case second is? So it is falling down. So yes. Let us check how it is falling down. So it is falling down under gravity. What are you saying? how it is falling down. No, the equation I mean. Yes, now we got it, what you are saying. Displacement under gravity what is happening with my hands? Under gravity minus h. Right, students, this is what? Velocity under gravity minus u minus v, and third case, yes, student, very nice, acceleration under gravity this is minus g. So in both cases, notice acceleration under gravity I have written here also. So this remains the same thing. Now the next part, one-dimensional motion. One-dimensional motion. One-dimensional relative motion. Relative motion, so this is very easy topic, no? They are what? One relative to another. No, sir. This is not about that relative that we are talking about. This is about physics relative. Oh, yes, student. I forgot it completely. So, the thing, let's draw with the diagram. Even before the diagram, I need this. Suppose two objects A and B, A and what? B. Yes, sir, we have supposed. Now, suppose this is frame of reference for A. A is supposed to be here. So what A? This is B, and I would actually what do? Make it move. So this is XA distance, right, student, and this is XB distance. Okay, this is also moving in this direction, and this is what I say VA, and this is VB, right, students? Yes, sir, this is very easy. This is Y, this is X coordinate. Then I would write what? Then XAB is XA minus XB. Right, students? Relative motion. So what should I write? Relative motion of A with respect to B. Right, students? This is what it means. Relative motion of A with respect to B. So why did you write motion? This is displacement. Relative displacement. Yes. Relative displacement. Yes. So sometimes you have to be very careful. So sometimes we have to be so careful with physics. It can't actually, it is very tough master. Yes, student, it is. Science is a tough master. And a great servant, of course. Also, XB is what? XB minus XA. What it is? This implies relative displacement of B. So first write B. So B with respect to A. Right, students? So definitely, sir, this is actually the thing, na? So what should I say? About what, sir? Can I write also VAB VA minus VB? This is what differentiation of this, na? With respect to time. Yes, sir. And this is what? This is VBA VB minus VA. Okay. So can you actually tell by an example this what is happening here? So let me tell you by an example. Suppose here B velocity I am taking to be 20 meter per second. This is what? 10 meter per second. Okay. Then relative velocity between these two is what, student? 20 minus 10. Then this comes out to be 10 meter per second. Okay. So this is the relative velocity between these two bodies. So suppose you are going with 20 meter per second and I am going in the same direction with 10 meter per second. Okay, so what happens? That relative velocity between us is 10 meter per second. And of course, I would never catch you because 10 meter per second you are ahead of me. So this is the thing. So you are behind us. So it is not we are ahead of you, you are behind us. Yes, students. So acceleration AB A it is relative acceleration of A and acceleration of B. Relative acceleration of A with respect to B is what? Acceleration A minus acceleration B. And I should write it relative acceleration of A. Now I eat up A with respect to B. Okay. Same goes here. AB minus A. Relative acceleration of B with respect to A. So we have understood. Now let me drive an actual general formula. What means of all this? So what could be the general formula? So you would tell us. So general formula, see, I would write V relative is what? V observer minus V, sir, you wrote in a wrong way. It should be object, no? Object, yes. V object minus V observer. Oh, the marker. V observer. Oh, sir, we were so happy the marker is not working. So, V object observer. So, V object minus V observer. This is the meaning of relative velocity. Wow, sir, beautiful it is. V object, V observer, whatever you say. So the thing, velocity of approach and separation. Velocity of approach, separation. So let me discuss the two. So approach is basically what, students? Two objects are approaching each other. Yes sir, we know this. So this is you and this is not you. This is I. This is me, A. I'm moving in this direction. This is B, U, and this is you approaching me. Okay. So this is what approach case. Approach case. Now I will explain this whole thing in mathematical form. So can I write, students? X A B is what? X A and minus what, student? Now B is for going into the negative x direction, so I would write minus xb. Yes sir. Xa plus xb. Right, student? Yes sir, we have understood this thing. So the thing, actually, yes. So yes. I think an ant was there. So not let's xa minus xb, and this is what? Yes, approach, and this is also separation. Now we will discuss separation. That what it is? Yes. This is also A, me, and this is you, B, and you are going into this direction. So what should I write? Sir, this is XA, B, XA positive, and this is also you going into the positive direction. So I would write XA minus XB. Okay. So velocity I was talking about. So let me actually write. This is separation we have discussed, relative distance. So velocity term comes to be velocity of approach is what, student? Sir, it is VAB, VA plus VB. Yes sir, you are differentiating XA, XB. So the next part, separation. Separation case is what? Separation velocity? Yes sir, it is VAB, VA minus VB. Differentiating the students, this value, differentiating XAB, yes, VA minus VB. Now, sir, what if both the objects, case 3, if both are objects going into the reverse direction, opposite direction, this is me, A, and this is I going into the negative direction, and this is you going into the positive x direction. So what should I write? Velocity of separation, I would write VA minus VB. Right, students? So how you came into this play? See, student, this is what? Minus XA. Minus XA, negative X direction, and this is what? Positive. So positive X direction, positive X direction. So XB, X direction. So this makes differentiation minus VA minus VB. So this is the thing. If you want to reverse the order, you can actually say without sign this becomes velocity of separation. Velocity of separation. This becomes VB plus VA or VA plus VB. Right now, students. So generally a thing. So when a velocity of separation word comes, you don't actually need to put the sign. Just can add up the thing. Next part. So what is the next part? Riverman problem. Riverman problem. Riverman problem in one dimension. In one dimension. So this is the man and it is going up his stream. This is the man. This is me. Not me. Let it be me. Because you would say, sir, you have not drawn us beautiful. So this is me. Going in what direction? U. Yes, very nice. This is the I am going with u velocity. The river is going with u velocity, and this is me going with v velocity. Yes, sir, we have understood. So what should be my total velocity? U plus v. So let me write the thing. Velocity of river. What should I write? River current? Positive u. Velocity of man in still water. In still water. Let me note it is still water velocity. And it is what? Positive v. Positive v. Okay. So what the equation becomes? So you would tell us the equation of man with respect to river. Velocity of man with respect to river is what? VMR, and it is what? Positive V. Then the actual speed of man in river, actual velocity of man in river is what? VMR plus U. So it should be VR, na? VR, velocity of river. Yes, student, this comes out to be V plus U. The next part. Case second. So this is first case, this is second. This is again I am in river. Okay, in this river, and I am going again with same direction, and this time I am going against river flow. Okay, yes sir, we have understood the thing. Then what my velocity becomes? V minus u. So I would write what is it? The same things. Yes sir. Velocity of river Vr u minus, yes, in negative direction. This is velocity of man with respect to river, of course in still water. Okay, Vmr, this is what? Positive V. Then actual velocity of man is what? Vmr minus plus, it would come plus, and this is Vr. Relative velocity formula, na student? Yes sir, V minus u. So this is the thing. Velocity of man, this is the thing. The next part and the last part, 4 equations of motion. Let's discuss the 4 equations of motion. Four equations of motion. Last topic of today. First, V is equal to u plus at. U plus at in vector form. This is S ut half at square. Third equation is what? V square u square 2as. Yes sir, this is what should I write? V square u square 2as. Now student, let me ask you a question. It should be cross product or dot product with these things. So it should be written in this way. V dot product V u dot product u plus 2as, a dot product s. So this is the form. Fourth, s u plus half a 2n minus 1. Again acceleration. Now you would ask how this is becoming displacement. This is vector quantity and displacement is a vector quantity. So let me write down in here. Acceleration is a vector quantity and it is dependent on what? Velocity. Yes. So then it should be dependent on what? Displacement. Yes sir. And the reverse is also true. So you see, from displacement you get velocity, and velocity, so you get acceleration. So all the things in Newton's equation of motion are vector. Thank you.